Welcome back to Simply Explain All, where we uncover the hidden mechanisms that shape our modern world and global economy today. Have you ever wondered how a simple hole in your wall could determine the fate of two powerful Asian nations? Today, we explore the 50-year rivalry between South Korea and Japan, driven by a single technical decision made in 1973. We must travel back to 1973, a pivotal year that presented a difficult crossroads for these two developing economies. At that time, both nations were struggling to modernize their industries and provide stable electricity to their rapidly growing urban populations. Japan was ahead in development, but their electrical grid was becoming a complex web that would soon face a massive challenge. Both countries primarily used the 110-volt standard, a legacy system influenced by early American electrical infrastructure designs. However, as heavy industry began to rise, the demand for power surged, pushing the old electrical grids to their absolute limits. Then came the global oil crisis, a devastating event that forced every nation to reconsider how they produced and consumed energy. In South Korea, the leadership realized that energy independence and efficiency were not just economic goals, but matters of national survival. The existing low-voltage system resulted in significant power loss during transmission, wasting precious resources that the country could not afford. Enter Professor Han Man-chun, a visionary academic who boldly proposed a radical solution that would change South Korea forever. He argued that upgrading the entire national grid to 220 volts was the only way to ensure efficiency. His logic was grounded in basic physics, asserting that higher voltage would drastically reduce the energy lost as heat in wires. Specifically, doubling the voltage would reduce the current by half, which cuts the transmission loss to just 1/4. However, the proposal faced immediate backlash because changing the voltage meant replacing every single transformer and appliance in the entire country. Critics argued that it would place a heavy burden on citizens who would have to buy new devices or expensive adapters. The debate raged on, balancing the immediate financial pain against the theoretical long-term gains that Professor Han was promising them. Meanwhile, Japan faced the exact same dilemma, but looked at their vast, established infrastructure and hesitated to make the leap. For Japan, the cost of retrofitting millions of homes and businesses was calculated to be too high to be politically viable. They decided to stick with their 100-volt system, believing that stability was more important than a disruptive system upgrade. Back in Seoul, the leadership took a gamble, deciding that short-term pain was necessary for the nation's future industrial growth. The project officially began, marking the start of a massive national undertaking that would span more than 3 decades to complete. It was not an overnight fix, but a 32-year marathon that required patience, consistency, and massive public cooperation. The total investment reached a staggering 1.4 trillion won, a colossal amount for a developing economy at that time. The government launched nationwide campaigns to educate the public about the changes and how to safely use the new power supply. House by house, street by street, the physical interface of the nation's energy consumption was being rewritten by thousands of workers. As the years passed, the grid transformed, creating a robust highway for electricity that could support heavier loads with less waste. This upgraded infrastructure laid the groundwork for the explosion of heavy industry and electronics manufacturing that was about to arrive. While Korea streamlined its distribution, Japan's grid remained fragmented, struggling with the limitations of lower voltage transmission in urban areas. Higher voltage meant fewer substations were needed to push electricity over long distances, simplifying the entire national grid architecture significantly. The economic savings began to compound, recovering the initial investment costs through billions of won saved in prevented energy loss. Today, the energy saved annually by this efficiency is equivalent to 1.5 times the total power consumption of Jeju Island. This foresight placed South Korea's electrical grid efficiency among the highest in the world, a hidden advantage for its economy. In contrast, Japan's decision to stay with 100 volts began to show its cracks as modern appliances demanded more power. High-power devices like large air conditioners or induction cooktops often require expensive rewiring work in typical Japanese households today. The limitation is even more critical with electric vehicles, where lower voltage means significantly slower home charging times for drivers. Upgrading the system now would cost an astronomical sum, leaving Japan trapped in a technological lock-in of its own making. But the most surprising consequence of this voltage divide was the unintentional creation of a powerful trade protection barrier. Japanese electronics, which dominated the world in the 80s, could not easily be sold in South Korea without costly modifications. Because they were designed for the unique 100-volt domestic market, they simply couldn't be plugged into Korean homes. This technical incompatibility created a protected space where local companies like Samsung and LG could grow without crushing competition. They had the breathing room to develop their own technologies, supply chains, and brand loyalty among the South Korean population. Furthermore, South Korea's choice aligned them with the global standard, as most of Europe and Asia also use 220 volts. This meant that Korean products could be exported to massive global markets with minimal changes to their internal power components. Japan, however, fell into the Galapagos syndrome, developing highly advanced products that only worked within their own unique island ecosystem. Their domestic dominance became a trap, as adapting their specialized 100-volt products for export added cost and complexity. Fast forward 50 years, and the results are undeniable in the competitive battlefield of the American home appliance market. Once mighty giants like Toshiba and Sharp have largely retreated, selling their appliance divisions or shrinking their global footprint significantly. Meanwhile, the Korean titans hold the number 1 and number 2 spots, dominating living rooms and kitchens across the globe. It is a fascinating case study of how a boring infrastructure decision can ripple through decades of economic history. Professor Han's vision was not just about wires and volts. It was a strategic masterstroke that prepared a nation for the future. Today, the bright lights of Seoul stand as a testament to the courage of making difficult changes for long-term prosperity. The legacy of that decision lives on every time a Korean device is plugged in, delivering power efficiently and reliably. It serves as a powerful lesson for leaders everywhere about the difference between short-term convenience and long-term strategic vision. In an era where energy drives the digital economy, the efficiency of the grid is more important than ever before. South Korea is now better positioned for the electric vehicle revolution, thanks to a grid that can handle higher loads. While Japan continues to innovate, the anchor of their legacy infrastructure remains a challenge they must navigate in the coming years. Two paths, chosen 50 years ago, led to two very different destinations in the global economic landscape of the 21st century. From a simple socket to global dominance, the story of voltage is the story of foresight, sacrifice, and economic victory. It reminds us that the most boring parts of our infrastructure are often the most critical foundations of our national wealth. As we move toward renewable energy, the lessons from 1973 are more relevant today than they have ever been. Perhaps the next great visionary is sitting in a classroom right now, thinking about how to upgrade our world again. The lights of Asia burn bright, powered by decisions of the past, illuminating the path for the generations of the future. So the next time you plug in your phone, remember the immense history hidden behind that two-hole interface on your wall. Thank you for watching Simply Explain All. If you enjoyed this deep dive, please like and subscribe for more fascinating stories. Let's take a moment to appreciate the technical design of the Shuko plug used in Korea, known for its safety features. In contrast, the flat pin design used in Japan is simpler but offers less secure retention and grounding in some older configurations. During the transition, The Korean government had to implement massive recycling and exchange programs to manage the obsolete 100-volt appliances. Interestingly, the upgrade also provided an opportunity to enforce stricter safety standards, reducing the rate of electrical fires over time. The project stimulated the domestic materials industry, as thousands of kilometers of new cabling were required to rewire the entire nation. Connecting the mountainous terrain of Korea was a feat of engineering, made more efficient by the physics of higher voltage transmission. Many older Koreans still remember the transition period, living in homes with dual voltage outlets and using clunky transformers for years. The humming red transformer box became a household staple, a temporary bridge between the old American standard and the new Korean future. Japanese utility companies have revisited the idea of upgrading multiple times, but the disruption to society is now deemed impossible. While Japan has high-voltage systems for specific uses like the Shinkansen, the residential grid remains stuck in the mid-20th century. Ultimately, the cost of inefficiency is paid by the consumer, hidden within the transmission fees and base rates of their monthly bills. Modern smart homes require stable power, and the 220-volt standard provides a solid backbone for the Internet of Things. Industrial automation relies heavily on consistent voltage, another area where the early infrastructure upgrade paid massive dividends for Korean manufacturers. The trade balance in electronics shifted dramatically as Korean brands moved from being budget options to premium market leaders globally. Consumers voted with their wallets, often unaware that the product's reliability was partly rooted in the manufacturing standards of its home country. The district of Gangnam, now a symbol of wealth, was just rice paddies when the decision to upgrade the voltage was made. Tokyo remains a vibrant metropolis, but its infrastructure density now acts as a barrier to the kind of sweeping changes Korea implemented. Future grids will need to be even smarter, and having a higher voltage baseline makes integrating renewable sources significantly more manageable. Solar energy integration is the next frontier, and efficient transmission is key to moving that power from remote farms to cities. The engineers of tomorrow are standing on the shoulders of giants like Professor Han, looking toward a wireless and sustainable future. Sometimes, to move forward, you have to unplug from the past, no matter how comfortable or familiar it may feel. Korea's rise from the ashes of war to a leading global economy is a story of bold choices and relentless execution. Japan's story is one of early success and subsequent caution, a reminder that being first does not always mean staying ahead forever. While Japan is still a massive economy, the gap in per capita wealth and industrial dynamism has closed significantly over time. The billboards in Times Square tell the story better than any statistics can, showcasing the global dominance of Korean consumer technology. From Berlin to Brazil, the decision made in a small office in Seoul is impacting how families experience entertainment and daily life. It also powered the semiconductor revolution, as stable and efficient electricity is the lifeblood of chip manufacturing facilities. South Korea's dominance in memory chips is built upon the same foundation of infrastructure investment that began with the voltage upgrade. Global trade relies on the seamless movement of goods, and standardization is the invisible grease that keeps these gears turning smoothly. We should honor the technocrats and scientists who often work in the shadows, making decisions that politicians take credit for. History is not just about wars and treaties. It is also written in copper wire, transformers, and the voltage of our homes. Understanding these physical principles gives us the power to decode the economic reality that surrounds us every single day. We are more connected than ever, and the quality of that connection depends on the physical infrastructure we choose to build. As the sun rises on a new era of technology, the competition between nations will continue to evolve in unexpected ways. Artificial intelligence and robotics will demand even more energy, posing the next great infrastructure challenge for both Korea and Japan. Will Japan eventually find a way to upgrade its grid, Or will it find a different, innovative path to efficiency? Will South Korea maintain its lead, or will complacency set in as they enjoy the fruits of their past labor? Only time will tell. But the lesson of the voltage upgrade remains a timeless example of bold, strategic governance. Innovation is a process of constant replacement, of letting go of the good to make room for the great. We hope this story has illuminated a corner of history that you might never have thought about before today. In the end, it is human collaboration and vision that turns raw physics into prosperity and comfort for millions of people. Like a ripple in a pond, one decision can spread outward, touching lives and economies far beyond its point of origin. From our perspective here on Earth, these differences seem huge, but they are all part of our shared human journey. At Simply Explain All, we are committed to bringing you these hidden narratives that explain the world around us. Your time and curiosity are appreciated, and we hope you leave this video with a new perspective on everyday things. If you found this interesting, check out our other videos where we explore more economic mysteries and historical turning points. Don't forget to hit the like button, share this with a friend, and leave a comment with your thoughts below. We read every comment and love hearing your suggestions for what complex topic we should simplify for you next. This has been Simply Explain All, simplifying the complex and revealing the extraordinary in the ordinary world around us. A final note on safety. The grounding system in the Korean standard is superior for protecting sensitive modern electronics from surges. This is crucial for computers and medical equipment, adding another layer of reliability to the South Korean infrastructure advantage. Many older Japanese outlets lack this integrated grounding, requiring awkward external ground wires to be screwed in manually. It is a small inconvenience, but multiplied by millions of users, it represents a significant friction in user experience. In hospitals and laboratories, stable and grounded power is a matter of life and death, not just economic efficiency. Lower energy costs for manufacturers mean more competitive pricing for exports, giving Korean goods a slight edge in global markets. Industrial electricity rates in Korea have historically been kept competitive, partly due to the efficiency of the national transmission grid. The chaebols, or large family conglomerates, were the primary beneficiaries of this state-led infrastructure drive in the 70s. But the benefits trickled down, creating jobs and a rising middle class that could afford the very appliances they manufactured. The modern Korean lifestyle, filled with high-tech conveniences, is directly supported by the robust power grid built decades ago. Resilience is another factor. A modern grid is better equipped to handle natural disasters and recover quickly from outages. Japan, prone to earthquakes, faces the double challenge of maintaining an aging grid while preparing for constant natural disasters. Korea has also adopted advanced maintenance techniques, allowing work on live wires without cutting power to the consumers below. Innovation continues with floating solar farms and smart metering, keeping the grid at the cutting edge of technology. Smart meters allow for real-time monitoring and pricing, encouraging consumers to use less power during peak demand hours. This digital layer on top of the physical grid empowers citizens to be active participants in the national energy economy. To summarize, 110 versus 220. It seems like a small number, but the multiplier effect is massive. It is the ultimate example of the butterfly effect in economics, where a small initial condition leads to vast differences. The Korean wave, or Hallyu, is built on an economic foundation that allows creativity and industry to flourish side by side. We hope this deep dive helps you appreciate the invisible wires that power your life and the world economy. Energy is the fundamental currency of the universe, and how we manage it defines our civilization's success or failure. From the bustling streets of Seoul to the neon alleys of Tokyo, the story of energy continues to unfold. This video was researched and produced with care to bring you accurate and engaging historical and scientific information. Bonus fact: North Korea also uses 220 volts, but their grid suffers from chronic shortages and poor maintenance. It proves that having the right voltage standard is only the first step. You also need the resources to power it. Thank you for watching Simply Explain All. Stay curious, stay questioning, and we will see you in the next video. Click the video on the left to learn more about economics, or the one on the right for history.